The overall goal of this procedure is to synthesize iron-doped aluminosilicate nanotubes of the imogolite type with defined textural and surface properties and a reduced band gap with respect to proper imogolite.
This method allows preparation of iron-doped nanotubes with a maximum iron content of 1.4 weight% by either direct synthesis or post-synthesis loading.
The main advantages of post-synthesis doping is a simplicity of procedure, as doping occurs by ionic exchange of aluminium in the outer surface of preformed nanotubes.
An important consequence of iron doping is that the imogolite band gap is lowered from 4.9 to 2.8 to 2.4 electron volts, which is particularly relevant for photocatalytic and semiconductor applications.
Surface iron 3 sites form ducts with an ionic azo dyes, which can be used to investigate electrostatic and ligand interactions at nanotube surfaces.
Visual demonstration of this method is critical, as the formation of nanotubes strictly depends on using the proper synthesis conditions.
To begin nanotube synthesis, in a dry environment, place 187.7 milliliters of double distilled water in a 2-liter beaker. Add 1.3 milliliters of 70% perchloric acid to obtain an 80 millimolar solution, and place the mixture on a stir plate. Using a graduated pipette, place 8 milliliters of aluminum trisec butoxide in a small beaker. Add 3.8 milliliters of tetraethyl orthosilicate with another graduated